Alright, so now we discuss um, the expansion of the universe. Basically, I want you to consider three different situations and why it's impossible to see an expanding universe when you're part of it, because you yourself are expanding. Now look at an atom. It's made of a nucleus and an outer shell. There's space in between. Over 80% of an atom is space. Space-time. If space-time is expanding, then an atom, let's say 4 billion years ago, would look totally different from an atom today. If the space-time between the shell and the nucleus has expanded, and the space-time dimensions of the particles themselves has expanded, this will be a much bigger atom today than it was time ago. And also, if you have a ruler, a 1 meter ruler that was made 4 billion years ago, by today's money, it will still look a meter, but it would actually be twice as large if we scale it up by 2. So, if someone from a universe 30 billion years from now was to go 4 billion years from where we are and take a ruler from there, and then come back to where we are and take a ruler from there, it will see that this ruler is twice the dimensions of that one. And even men are not exempt from this. If a man that was created 4 billion years back was to be compared to a man now by someone from a future time, he will find, if you could take a man from 4 billion years back, or even a man from 30 billion years into the future, but let's just hypothetical. If men were created 4 billion years back, which it wasn't, but hypothetical, a man from 4 billion years back, you take him away, and you bring a man from here, take them away, and compare their size, this man will be twice as big as that man. But if you put him back in his world, and he makes a 1 meter ruler, and you bring that ruler into this world, it will actually be half the size of what we call a meter ruler. When he measures his atom with his ruler, you have the same value as what we get when we measure our atom with our ruler. Everything's been scaled up. Okay, so if he walks at 1 meter a second and takes him 1 second to walk across this meter, if he was to come into this world, we will see him taking 2 seconds to walk across this meter. Okay, but in his mind, in his consciousness, he would have walked 2 meters. But we would have only seen him walk 1 meter, but in his consciousness, he sees himself say, oh my goodness, this is a long way, and it would have taken him 2 seconds. Okay, but if he goes back in his world and walks that same meter, what he calls a meter in his head, in his consciousness, is actually 2 meters in our head, in our consciousness. Okay, so in his consciousness, he sees 1 second going by. In our heads, that would have only taken him halfway. In his head, when he sees 1 year going by, in our head, we would have only seen half a year going by. If it was more exaggerated than that, because the expansion of the universe from early expansion, it expanded by something of the order of 10 to the 30 something in terms of each dimension. Yeah. So time as well expanded because it's space time. Yeah. The time it gets from here to here changed. Yeah. So in the early universe, yeah, what took a day, yeah, if walking from here to here took a day, yeah, in our universe, it will take, multiply it by the scale, by the factor that you expanded by. Yeah, let's say a billion. It will take a billion days in our minds to see someone from this world walking from here to here. So if we're describing things that took place in a world where the dimensions were much, much smaller than what we have here, if we go to this world and we see a day, we see if someone from this world goes into this world, yeah, everything will be so small that what they call a billion days in his consciousness will only be a day. Yeah, that's the problem. Or what they call 10 to the 33 seconds will most probably be a day to him. Okay. So that's how you get the discrepancies, yeah, that are there between the past and now. Yeah, if we're describing things that took place billions of years ago, we have to understand that if we're looking at it from the point of view of someone who's there, seeing it happening, we have to translate that into what that means in today's money. Yeah. If 4 billion years ago, it took 500 million years to create life, yeah, in today's money, that will probably be a couple of 100 years. If from the creation of Earth to the arrival of man took, let's say, no, if it, from the creation of the Earth to the arrival of life took 1 billion years, in today's money, yeah, that only took like a day or something, like something ridiculously small like that. Because the expansion is so much that I don't know what the factor is. I'm just guesstimating here. Yeah. So you can see how somebody can mistake this. Yeah. He can be describing things in today's money when he's actually looking at things from a different time. We're still doing it. So we shouldn't be seeing the Doppler effect. There must be another reason that's causing it. On YouTube, there's some interesting man that came up with a reason to do with electromagnetism rather than gravity. He rejects the whole concept of gravity, and it's just electronics or electricity and the electric field and magnetic fields that's responsible for what we deduce or imagine as the Doppler effect. I'm more inclined to go with that kind of reasoning, because if we've been scaled up, we shouldn't notice any difference. Our meter still looks like a meter to us, just the same as how this man's meter looked like a meter to him. Our atom will still be measured to the same value using our meter, just as he would measure his atom using his meter. Yeah. So in today's money, when we describe the past, we have to multiply it by a factor that slows time down. I don't know by how much. I haven't done the mathematics. I will, but I just can't bother. Anyway, just something for you to think about.